Alright, this is how we get the input. We don't need this anymore. Oh, this is just an old solution. Old solution, this is. Print the minimum number of moves. Alright, next iteration. So this is how we implemented this problem. We just iterate over the numbers, and if we discover, or maybe this should be while. If we discover a number that is not in an increasing order, meaning that its previous element is bigger than the current element, we should increase the moves, and we should increase the nums as well as 1, because like a move is incrementing a number by 1. That's pretty much it. We do the same friggin' thing over here. Exactly same thing. While this, we should also have int moves. It should start with 0. The nums I should increase, and the moves should also increase. And then we have to see out. This I think should run. Let me just run this locally. So what's the problem here? Try again. Yeah. Five. Yeah. The output was correct. Now I should just oh, wait a minute. What, we have a runtime error? Why? What the hell? We had like 200,000 element array and no problem. And we had problem with 10 elements. That's not good. I get it. Yeah, I get it. Is this gonna be better maybe? Oh, wait a minute. Yeah, I don't get why is this a runtime error. I really don't get this. Oh, I see. I see. I see. Obviously, this is a very bad problem. Like n was initialized here, so it was just stupid. So it was just silly for me to do that. It was an extra newbie mistake. Wrong answer. Oh, shoot. Oh, I see. I see. Maybe this will help. Maybe this will help. Um, shoot. No, 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 not the binary. Not the binary, man. Wrong answer still? Accept. Oh my god. Long. Just make everything unsigned long. Yeah, pretty much. Which is dumb, but hope it works. Accepted. Which one was the problem? This can't be a problem, right? Maybe int was not enough. But come on, like size is not that. Yeah, whatever. Permutations, next problem. A permutation of integer Yeah. All right, permutations. Yeah, this is even easier of a problem, I think. Probably. Who knows? Um, yeah, like we will have vector you know what what we're gonna have two vectors. One's gonna be and evens and another gonna be odds. And oh, it's just in vector and evens and odds. Yes, so we start from 1 all the way up to n. If that's the case, we should have evens push back I, and else odds push back I also. So if it's even, it gets pushed to even, and if it's not, it gets pushed back to the. So we should just print out evens and odds, basically. All right. So for auto in events, see out and this, and then we should just do the same for odds. Right, this should work, I think. Probably, who knows? Who the hell knows? Except for my CPU. 5 2 4 1 3. All right, this is good. I think this is good. Personally, I think it is good. CPP. Submit. Please, 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 please. Wrong answer. Oh, okay. If n is equal to 2 or n is equal to 3, we should see out no solution. No solution. And we should just return 0. This should suffice. This should fix the two problems over here. Yeah. And number spiral. This is a tricky one. This is a fucking tricky one. let's just go on. We have a number spiral. It goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 16. All right. If we make, so I think this should be clear. It should be clear that, all right, let's just handle the input. Let's just handle the input, you know, t integer. This is just test numbers. T integer, right? 0. Let's do this t times plus plus. Do these. C in. Y and X. Or pair. So this is basically it. Y and X. You do this many times, and that's probably it. Let's just prove that. This is working. We'll just prove that this is working. Yeah, we have our own edge G++. A out 3, 2, 3, 1, 1, 4, 2. 2, 3, 1, 1, 4, 2. Yeah, that's it. That's it. This works. The input just worked. Shoot. What are we going to do now? Yeah, so it's pretty clear that like the relationships of like between the numbers and coordinates of this table can be like described mathematically using different formulas. Like one easy observation that I made was that this first number here is just 1, which is 1 times 1. Then we have 4, which is 2 squared. Then we have 9, which is 3 squared. Then we have 16, which is 4 squared. So the end of every spiral, every layer of the whole spiral is the number of layer squared, pretty much. So the 5th layer ends in 25, 4th layer ends in 16, 3rd in 9, and so on and so forth. Yeah. And task is to find out the number. So we have y and for t, auto t in tests. Yeah, and we have to basically see out spiral at y x, pretty much. This is what's gonna happen. So yeah, the one observation was that we have a nth layer, we can know the end of that nth layer. Another observation is if we are looking at numbers on this diagonal, we have 1, 3, 7, 9, and 21, which is 3 is 4 minus 1. 7 is 9 minus 2. 13 is 16 minus 3. So if you think about it, if x equals y, this is a very special case which can be described mathematically, and it's gonna be x squared because why? Because it's actually x times y, but okay. X minus x minus 1. And I think this is gonna be, this for sure is gonna be like right for every element which is located on a x equals y. Right. Squared minus 9 minus that. Else, if we have a case of x is more than y, and else, which is gonna be y is less than, y is more than x, but I'm just not gonna write it in the code itself. I'm gonna comment it out. So what's happening here? We have x more than y. X more than y are gonna be like all the characters that are high up the horizontal, up the diagonal line. So x for this is gonna be 3, and y is gonna be 2. X is gonna be 4, y is gonna be 2, and so on and so forth. Now we have to make some observation here. Like, what is 8? How do we get 8? So 8 is 9 minus 1. 11 is 10 plus 1. I think what we have to do here is that we have to get the top number. Get the top number. And basically just And the answer is going to be top minus y. Plus 1. Top minus y plus 1. This is going to be it. And the lower numbers are I think x is just x indicates the layer, right? This is a third layer. Top is 0 at first. If x is an even number, now if x is an odd number, top is just x times x, right? Yeah. Else, top is like previous number's maximum, like 10. Previous maximums plus 1. Previous maximums plus 1. Plus 1. Yeah, this is the top number. And we should just see out top minus y plus 1. That's basically it. Oh, this observation of top, this observation that x is equal to the layer number only works above this. It only works above the diagonal. Over here, the y is going to represent the thing. So now we should think about what happens, like what happens behind this. Oh, let's check if this works for one top. Yeah, and now let's just think about what happens where essentially yeah, below the thing. So 4, it just 2 times 2. 16, it's just 2 times 2. 15 is 16 minus that. 18 is 17 plus 1, which I don't really get. Yeah, basically it's about y. Left number, we have this like left number here. All right, 6 is 5 plus 1. 18 is 17 plus 1. 15 is 16 minus 1. Okay. So 4. Oh yeah, 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 yeah. Yes, 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 yes. Oh, damn it. Just constantly thinking about other things also. Constantly. Alright, we have to come up with the left number. Yeah. At first, we just have to come up with the left number, and then we'll just have to come up with the right number. No, left number. In this case, also delete this. Also delete this, yes. No, no. What the hell was that? So, if it's an odd layer, the left thing is gonna be y plus y times y. Y times y. And then the answer is y times y plus 1. Y times y plus... No, this is odd numbers. Plus y minus this basic. So many ifs and else's. I don't like this, to be honest. I don't like this. But it is what it is. So we have if this, and if this. So else the left is gonna be oh, I think that's it. But who the hell knows, to be honest. Oh, we also need Endel at the end of every C out. Fuck you, Endel. Yeah. Endel. Endel. Mm. So I made one mistake. I have made one mistake. But one mistake. 15. And I said 13. It should be X here. X. I think this is now correct. A out. Yeah. Wrong answer? What the hell? What the heliante? Yeah. I hate this because you have to think about like always you have to think about types, which is hella which is like yeah, hella Submit. Boring. Wrong answer. Again, wrong answer. You know, what I should do one day is to just go through all the data types of C++, like really seriously, like up to the values, to know like which value, yeah, and now it's accepted, to be sure that which data type can represent which values exactly, so that I don't have to like just use the maximum, the biggest data type for the problem. This is not going to be efficient. All right, I think I have one more problem that I need to solve today. I need to solve it, but I don't remember which it was. Oh, it was a palindrome reorder. Yeah, that's easy. That's easy. I'm gonna solve this easy. Yeah, we have the first couple of problems solved. We still got like a lot more. We still got a lot more work. This is a lot of work to do. Additional problems, a lot of work. This is gonna be a lot of work, I know. GCD subsets. Counting problems, a lot of work. Advanced graph, a lot of works. A lot of work. Construction, I don't even know what that is. Bitwise operation, it's gonna be tricky, I know it. It seems easy, but it's gonna be tricky for me because I suck. Interactive problems, I'm not sure what it is. It's gonna be hard. Advanced techniques, of course hard. Geometry, yuck. That is gonna be hard. String algorithms. The first one, I don't know how to solve it. I read it, I don't know how to solve it. And you can see the 2,000 people opened it and didn't solve it. Mathematics. Binomial coefficients. I don't know. I'm not sure. Fibonacci numbers. Come on, that Fibonacci is pretty easy. Tree algorithms. It's gonna be a lot of work. Range queries for sure. I think we'll have segment trees here. Graph algorithms is gonna be a lot of problems, a lot of hard shit to deal with. And dynamic programming, a lot. I don't get dynamic programming at all. I think I'm a noob at dynamic programming. Sorting and searching, it's gonna be hard, but whatever. Yeah, let's just do the palindrome reorder because it's an easy problem and we should do it. All right. Hell. God damn. Roxanne, string S. We have a string S, and then we're gonna read it, and then we're gonna do a map of chart int 10 to the 6. 2 billion. So 6 is 6 zeros. So yeah, int will take care of this. Int should be enough. Um, Occurrence. No, not auto, char. Char. How do we do this? Occurrence. Yes. What we should do, like, is we should yeah, so I got this thing. I don't know how it works, but if v divided by 2 no, int, what's that, count evens, count odds. Since we're doing this, I think we should, yeah. No, let's just keep it this way. Because I'm just gonna fuck it up, I know it. Let's not fuck it up. If that equals to 0, basically, left is like, let's push back to the C and right equals to C plus right. And we should hell. I think we should two. Yeah. Yeah. Yeah, fuck this. Fuck this, yeah. This should work. I'm not sure that it will work, but it should work. Odd. Alright. Empty character constant. Oh, not M, but occurrence. This good? Hell. 0. Is this good? Fuck you. Compile. M. Occurrence, man, not... Yeah, this is not. do it again. Fuck. What's your deal, man? What is your deal? Oh, where is C, by the way? Where is C? Please be correct. Please be correct. Oh, we have a wrong answer. How is this wrong answer? How is this wrong answer, man? A. This is A and A. And this is 3 bytes also, user output. Oh. A. What the hell? What the helly? What the heliante? Correct output. Test output text editor A. User output A and something else. So this is correct, man. This seems correct to me. I'll just get back to this. Because I don't have time today. I think it was a good uh, I think it was a good thing that I did. So I just read a problem, came up with a pseudocode solution, and then went to a next problem, pseudo solution, four problems with the pseudo solution, and then at the end of the four problems, just implement all four of those. This is faster because if I just dive into the implementation, I get tired and I don't have enough brains to think about the next problem. So that's it. It was a good stream, I think. CSES, I think I will finish CSES in a month probably. So yeah, good stream.